So we're going to look at a phase change graph. So just like we did your phase changes, what we can do is we can represent this on a graph, or sometimes you'll see it called a phase change diagram. So the whole point of a phase change diagram is that it's a graph. Now along the x-axis, you have heat energy that is being added. Okay, so from left to right, your heat is increasing. Now from bottom to top on your y-axis, our temperature goes up. So as heat is added across your x-axis, and this is typically over time, is how we usually measure it, and this is temperature rising over time. So we always start with and it's got pictures here for you just as a visual. We always start with the solid. So whenever you see your phase change graph going from left to right and it goes up, you always start with the solid, right? At the lowest temperature, the lowest amount of energy, your object, whatever your substance is always going to be a solid. Now, what happens is as it goes up, you're adding heat. So heat is added, temperature rises. And you get to this first crook, this is your melting point. So then heat is added, but temperature does not go up. Okay, so even though we're adding heat, temperature is not going up because all through here, this flat part, this is where your heat is being used to break the bonds of your substance, and then they're reforming. So you're breaking bonds here, which is why temperature doesn't go up, because it's being absorbed into your substance. So here, it's melting, beginning to melt, melting, 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 and then boom, it's now a liquid. So at this point, your substance is liquid. So it's increasing in heat, temperature rises, it's still a liquid. We get to this point, and this is our boiling point. So at our boiling point, this is where it's a liquid, but now it's starting to boil. So it's starting to become a gas, but this is the boiling point. So it's starting to boil. It's boiling, 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 melting, or breaking your bonds. So bonds are breaking, and then boom, here it's totally a gas. And so now we keep adding heat, temperature rises, and it becomes a gas. Okay, and your phase change diagrams will stop there because you can't create plasma through adding more heat. So basically, along here, we're looking at your phase changes, but in graph form. So here, we're looking at melting. So our solid is a solid. It begins to melt. So it's melting right through here. It's a liquid. Then it starts to vaporize or evaporate. So here it's vaporizing, it's becoming a gas. Now, vaporizing happens anytime it becomes a gas. Evaporation happens at low temperatures, but we're not going to make a huge distinction. Now, here it's a gas, so it's totally a gas. Now, if you would read the graph, and sometimes you'll see it where it's flip-flopped so that it starts high and it comes down to the right and temperature decreases. So this would be the opposite. So gas to a liquid is condensation. And then if we go from a liquid and we become a solid, then we are freezing. And of course, if we go from a solid to a gas and skip this whole liquid phase, then that's sublimation. So a phase change diagram or graph will always start with a solid and ends up with a gas. So you add heat and it begins to melt. At this point, it's now becoming a liquid. All of a sudden, right here, it's totally a liquid. And it goes liquid, liquid, liquid. It starts to boil. And then it's becoming a gas. Right here, it's all gas. So it's already become a gas, and it's going to stay a gas. And that's how you read a phase change diagram. Now, along the left on your y-axis, oftentimes we measure temperature, it'll be in degrees. So you might have, like if this was water, for instance, right, and typically we'll measure in Celsius. So if you have melting point, which is the same point as your freezing point. So melting and freezing point's the same. So if this was water, this would be 100 degrees Celsius. Right? If this was water, right? Because we know that at 100 degrees, not 100, should be 0 degrees. Sorry. This should be 0 degrees Celsius. Water freezes. And then if we go and we're here at boiling, we know that this would be 100 degrees Celsius because that's the boiling point of water. And then it would become a gas, obviously. So one other thing to point out is that your freezing and melting point are the same, and your condensing point, or the point of condensation, and the point of vaporization is the same because they're opposite processes, so they happen at the same temperature, right? So if you have a solid, let's say an ice cube, at 0 degrees, it's still the solid. But if we increase our temperature even the slightest, then anything above 0 degrees, it's going to start to melt, right? And so then we work the opposite way. If we have regular, let's say a glass of water, and we expose it to 0 or below degrees Celsius, then it starts to melt.